Hello, everybody. It's good to be here. I've just come from Arizona State University, where I'm on the board of the Global Institute for Sustainability, and everyone sends their regards. So, I'm going to move quickly tonight through far too many images, but it's important to remember that the Roman senators were given 3 hours. I won't take that. But they were also taught how to listen for 3 hours. You don't have that. But they used architecture as the mnemonic device. And so they would wander through buildings as a way of remembering their speech. So even as an architect, I'm just going to go wander through a construct. And I hope it's okay, because I'm going to talk about design for the circular economy in the ecological century. Right now I have the privilege of being the chairman of the new Meta Council for the Circular Economy for the World Economic Forum in Davos. We're 1/6 of the Meta Councils of this body. And when I asked why they picked someone other than an economist or a CEO, their answer was, you know, some people say that economists are trying to show that something that happens in practice can be proved in theory. And we thought we'd get a practitioner. So here we go. I think as a designer, as an architect, and now a writer, I guess, I think our job is, the first thing is to change the way we see. So if someone says, oh, my backyard, it's such a mess. And I could say, but to the butterflies, it looks better every day. I think we need to change the way we think. Because if you look at design as a signal of intention, one would have to ask, what were we thinking? So, think. And then we rearrange the furniture. And finally, when all else falls by the wayside, we build. So I'd like to start by talking about how we see. This is a poem from Hildegard von Bingen from the 12th century. She was a theologian, nun, and doctor, poet. Glance at the sun, see the moon and the stars. Gaze at the beauty of Earth's greenings. Now, think. See, gaze, think. What a delight God gives to humankind with all these things. Delight, beauty, delight. But then finally, all nature is at the disposal of humankind. We are to work with it, for without it, we cannot survive. Now, as I talk tonight, I'm not going to be talking about sustainability. You won't hear that word again. Because I wonder, if all we have is sustainability, I'd have to ask, how do you feel about the relationship you have with your spouse? And you say, sustainable. I'd say, I'm sorry. What, is this maintenance? Is that all we're here for? So this notion of usufruct, which is this idea that nature is here for our use, is really important. But remember, Thomas Jefferson in 1789 wrote to James Madison while they were designing the federal government's borrowing authority. And his suggestion was it be one generation. He thought it should be 19 years for a federal bond. And his point was, the earth belongs to the living. The earth belongs to the living. No man may by natural right oblige the lands he owns or occupies to debts greater than those that may be paid during his own lifetime. Because if he could, the world would belong to the dead and not to the living. The world belongs to the living. So what do we see and how do we see? Glance, see, gaze, think. Well, in 1992, we issued the Hanover Principles at the Earth Summit, and I wrote them in New York with a wonderful team, and they were designed for sustainability then. And the first was insist on the rights of humanity and nature to coexist. So we can now see, in terms of era, we can see centuries, and we can see decades, we can see years, we can see days, we can see minutes, we can see nanoseconds. So what do we see? This is an image that Al Gore sent me last week, because this will be the view from the Lagrangian point satellite. It's being launched by NASA, and it will be stationary and aiming at the Earth, always illuminated at a point between the sun and the Earth, the Lagrangian point. This will be the view. There is the moon. And so we're at the Anthropocene era, the era where humans have become the dominant species, and the planet is transforming to our effect. So if we look at what it means to be a defining century for humans, we could look at the 1700s, and I've come here, from Charlottesville, Virginia, where I had the privilege of living in a house designed by Thomas Jefferson. And when you look at the idea of equity coming from the issues of natural rights, converting into human rights, and then they morph again into the rights of nature itself with the Endangered Species Act. But if we look at the 1700s, we see the beginning of the collapse of feudalism, primogeniture, and divine right. How many of you want to go back to being serfs? Anybody? Anybody here royalty? How are we doing? So, human rights. Interesting. In the 1800s, after Adam Smith's Wealth of Nations, 1776, again, quite the year, we end up with the economic century. And we have the marketplace. And what do humans do? We develop capitalism, socialism. We develop responses to the concept of the market economy. And once again, the destruction of feudalism, primogeniture, and divine right from the markets. And then the 1900s show up. What was the abiding principle of the first industrial revolution? The only one I can find is that if brute force is not working, you're not using enough of it. And we end up with the pollution century. When did we give anybody the right to kill? Pollution, like a toxin, is a material in the wrong place. Is lead a good or a bad? Poor little lead. It doesn't know. Is a hammer a good or a bad? That depends. The value of a tool is in the intention to which the human puts it. A hammer can be a weapon. Lead can be solder. Lead can be a neurotoxin. Lead in the wrong place, your child's brain, is a terrifying thing. Solder is just doing a job. And if we release it to the biosphere, it becomes a toxin. So, when did we get the right to pollute? I don't know. And then in the 70s, we end up with discussions around sustainable development, maintaining something for future generations that will meet their needs. Well, yeah, good. Let's start thinking about that at the end of the 1900s. And then in 1992, very end of the 1900s, we had the Earth Summit. And as Maurice Strong, when asked as the Secretary General of the Earth Summit, was asked how many world leaders were at the Earth Summit, he thought, and then he answered, we had 124 heads of state, but no leaders. And if you look at the Earth Summit, what happened from that, from a business perspective, was eco-efficiency. And a very important idea would be less bad. Is being less bad being good? See, if less and bad are two negative numbers, I guess they become a positive, but unfortunately less is a relationship and bad is a human value. So you are, by definition, bad, just less so. And so is what we have for each other that will be less bad? So the idea of eco-efficiency is a very important one. But is it sufficient? And if your goal is 0, how exciting is this really? My goal is nothing. So what do you tell your children? It's too bad you're here. You're making it hard for me to be nothing. Or we'll say, let's reduce our carbon by 20% by 2020. Well, that sounds interesting until you realize, well, you still got the 80% emission, and by 2020, and you went down by 20%. And the other implicit signal to the children is you're telling them what you're not going to do. You ever tried that with the kids? I mean, this would be like me running out of here and jumping in a taxi and going, quick, I'm not going to the airport. Is this helpful? We're going to tell the world what we're not? Really? So, the question has to be the obvious ones. The questions have to be like, why would business make something it can't sell? Why would a business produce liabilities instead of assets? Who gave anybody the right to pollute? So, I think the defining innovation for the century we're entering now is ecology, and we will then bring together equity, economy, and ecology, which is the famous triad of the desire for sustainable work, and we'll show some diagrams on that. But first, I just want to point out that Peter Drucker had an astonishing first page of a book called The Effective Executive in 1984, and he starts by saying it's a manager's job to be efficient and do something the right way. But it's the executive's job to be effective and do the right thing. See? It's unfortunate, I think, that W. Edward Deming went to Japan after studying American women in the factories during the war and watched them increase productivity dramatically over the men who had been there by not having inspections because they refused to make products that wouldn't pass inspections. So they got rid of inspections. They just made perfect things. There you go. Anyway, and they made more of them faster, you know, because they talked to each other and sat in circles and threw away hierarchies and so on and so forth. And after the war, the men came back, and he was a statistician, and said, you should see what happened. They said, hey, we're hierarchical, we won the war, we're inspection-based, you're out of here. And he went to Japan and created the Toyota production system. The rest is history. So if you look at that, in a strange way, he was a statistician, so it's almost too bad it was called total quality management, because it was actually total quantity management. Because its sharpest tool is Six Sigma, perfection. This is numerical statistic metrics. See? So what is the right thing to do? Well, in their case, they were making armaments, because at the time, it was the right thing to do. But the question is, what are you making? What if you're making the wrong product? What if you're making a Hummer in a world that wants Priuses or Teslas or something, you know? Whoops. So what is the right thing to do? Because if you do the wrong thing, like polluting products or toxic products, and you do them perfectly, congratulations, you are perfectly wrong. See? Interesting. So, commerce is the engine of change. That's why I principally work in commerce, because we're fast. And Jane Jacobs pointed out there's the guardian in commerce. That's the syndromes of human survival. And the guardian is very slow and serious. It reserves the right to kill. Commerce is very quick, efficient, effective, and creative. And if you get the two together, you get what she calls monstrous hybrids. Because if you get the guardian into commerce, say with regulations, you slow it down. And I believe in regulations because society has every right to express its needs and concerns. On the other hand, I think regulations are really stupid because they represent a signal in design failure, which is a signal of immense stupidity. So business is doing something stupid that requires the state to say, stop doing that. See? So the question becomes, can we design things that don't need to be regulated because there's nothing to fear? What if we were waging peace by design? Well, my parents both spoke Japanese. My mother was the first American civilian woman into Japan after the Second World War. because she and my father, along with 199 other young American couples, had been trained by MacArthur to occupy Japan after the signature of the treaty in Tokyo Bay. And they went in without uniforms, without weapons, in unmarked jeeps, no paperwork. And they deployed around the country and took baths. That's how MacArthur occupied Japan. He waged peace as fiercely as he had waged war. So I was born in a traditional Japanese house. This is Katsura. It wasn't this one. This is the princely retreat. But it was a shogun summer house we lived in, a traditional house. And you live in these paper houses. And I remember at night, my mother would come in and sing songs to us because the farmers had come in to collect our sewage. Every night the farmers would come on the cobblestones. You'd hear them in the middle of the night. So my mother would come sing songs to us. And you're 3 years old and you're getting a song from your mother about poop. It was so cool. We just loved it. So we would just lie there and think about the farmers and the poop, and they were going off to the farms to make fertilizer, and then they'd bring the food in the next day. We just thought this was the coolest thing. And I always thought that cities and farms were one thing. This is the Netherlands. And I still do. So these are my defining moments. The other was this one. At the age of 5, I became fully aware of Hiroshima. And I couldn't understand it. I couldn't understand why people would blow each other off the face of the planet. I couldn't understand it. These are nice people. And I couldn't understand how you could do that. How do you make a city disappear in 5 seconds? Anybody know? How do you make a city disappear in 5 seconds? What is that? It takes so long to build, thousands of years. And poof, destruction is immensely quick. Construction is immensely slow. And so the presence of this concept of annihilation in a moment became something that really concerned me. And I couldn't understand it. So anyway, I went to college. I went to Dartmouth College as an art student with extremely urgent curiosities, 2 of which were, why did we blow each other up and how is it possible? So I decided to take physics, nuclear physics, with no preparation, of course. And the professor said, you can't do this. And I said, you're probably right, but I'm paying tuition and we're going to give it a try. And, you know, I can drop out after a few weeks if it's not working out, but let's give it a shot. So he said, okay, well, then you got to study the special theory of relativity to understand this. And so you've got to solve for this. And so I got this book and I went back to my dorm and I couldn't do it, of course. I stared at it, I got immensely frustrated. So I went to the fireplace and lit a fire and thought. And then I decided to go to the library and look up negative entropy. Because I was watching a log burning and I was thinking, this is entropy, we learned about that. Everything's going to chaos. It's a law, never to be reaggregated. Really? Well, I'm from Asia, so where's the opposite? So I went to the physics library and I couldn't find it. I found enthalpy, exergy, everything else, but I couldn't find negative entropy, the anti-chaos. So I went back to my dorm and I'm in total crisis. Obviously, I'm hopeless at physics. And then all of a sudden I saw something, which was, oh, the log is negative entropy. Obviously. And how did the log come to be? Oh, it captured dispersed materials and energy and aggregated them and concentrated them in an anti-chaos. And so then all of a sudden I'm looking at E equals mc squared and I'm thinking, wait a minute, I can actually solve this because look what's going on. See, what's missing? Well, life. Huh. So let's also, how many of you have solved this equation? It's fun, you want to? Here, let's take a minute. You know, I came out all night for this. Let's solve this baby. Ready? Where's the number? C. 2 is a relationship. Close. C, that's the constant, 186,000 miles per second. Very big number. Hurts my head. Close to infinity as far as I can tell. Oh, just in case you don't think it's big enough, square it. All right. So as big as you can think of, and then square it. Okay, good. So that is an immensely huge number, which means that if m is in any way a 1, a positive number, m, right, as in 1 hydrogen atom, then E is infinity squared for all intents and purposes. This is why Hiroshima disappeared. That is the atom bomb. So, then, if you think about that log and you realize, well, wait a minute, if biology is negative entropy, then what are the inputs? The inputs are solar energy, carbon from the atmosphere, nitrogen from the atmosphere. Isn't that interesting? We have income. Ha! But those are the only forms of income on the planet. So what do we do today? Right? We don't take this astonishing revelation of life itself. So I studied Crick. 9 years after discovering DNA with James Watson, 1962, he gave a lecture at the University of Washington entitled Molecules and Men. And his conclusion was to be a living thing. He was studying what he called the nature of vitalism. What does it mean to be alive? Pretty cool. And he decided to be alive, you have to have growth, you have to have income from outside the system to have growth. And that typically comes from the sun. And you have to have an open system of chemicals operating for the benefit of the organisms and their reproduction. And so as we all talk about these things, I started to realize then that if I ever became an architect, that I would design buildings like trees that capture carbon and nitrogen and make oxygen. Of course, it's sort of like discovering the obvious, don't you think? Seemed like that to me. Anyway, so while the German engineers were arguing about how you couldn't have a building operated by children, because I had it so the children would operate the building, move shades, open windows and stuff. I had the backup, but I didn't show it to them. And they said, you can't do this, you can't have children operating a building. I said, well then talk to the teachers, see what they need. So they were talking and the teachers are telling them, do you know the biggest problem we have here at these daycare centers? Finding things for the kids to do. How about wake the building up, put it to sleep, open a window. But what if they don't open the window? Well, then they get hot. What if they get hot? Well, then they're going to open the window. They're not brain dead, really. You know? So why not? Anyway, while they're arguing, I'm watching this kid eat the building. And I'm thinking, oh my goodness, they're eating the building. So I decided I needed to talk to some chemists, so I found, after a few years, I met Michael Braungart, ecotoxicologist extraordinaire, but also an astonishing chemist and thinker. But I started worrying about this issue of an open system of chemicals operating for the benefit of the metabolisms of the organisms. And so we articulated this notion of biological and technical nutrition that Crick had identified, you know, the fundamental order of living organisms. But what about the ones that we now make? And we talk about these having a life cycle, really? We talk about the end of life of products. Like when was the last time this was alive? Right? So we say end of use, not end of life. Why put a projection that this is living? Your phone talks to you, but I promise you, it is not alive, okay? So the idea that you'd have technical nutrition that can go back to industry forever gets very interesting. And what we really want are the services of these products, not necessarily the ownership of 4,000 chemicals, you see. So this became very interesting in terms of new business models and things like that. So when you stop and think about linear economies, you know, you could look at this. This is simply the United States sending trillions of dollars to China to get a bunch of stuff. Fine. It's a linear economy going this one flow direction. Notice this. See where that's going? Now, in the old days, during the Cold War, when you saw a diagram that had arrows going like that was known as mutually assured destruction, and those were missiles. So if you think about it, this is mad. How long are we going to keep this up? And then when you look at the materials we're sending, these little missiles, we have a spiral economy, actually spiraling down, and there's a gyre. I mean, there are the gyres in the Pacific full of plastic trash. So we get all this stuff from China, and we recycle a little of it. We put it in the holes in the ground. We burn some of it. We send some of it back if they'll take it, because the Chinese created a green fence because we were sending them toxic stuff. So they said, well, maybe we won't have it back, even if we send it to you. You know, anyway. And then they're releasing stuff, like we all are, into the oceans. And so we just said, wait a minute. If we shared biological and technical nutrients with each other all over, then this becomes a circular economy where everything's an asset. Wouldn't that be a smarter economic model? So the question then became, now that we see the world differently, let's change how we think. So the notion that we have a social market economy, and then we bring in environment and talk about sustainability is very important. So I just decided to create this fractal tile. This is the Sierpinski gasket in the fractal world. It's just self-similar to every scale, has no scale. It's made of itself. So you can run around this. So the economy corner of economy corner would be, are we making a profit? Because you're a business, obviously. I think we're pretty much all NGOs other than government. So I see all businesses as for-profit NGOs. Why can't we have missions? Of course, right? So we're just non-government, right? So if you're not making a profit, you're out of business, so you can't be a business, so you have to make a profit, of course. Then economy equity would be, are people earning a living wage? Equity in the economy would be, our men and women pay the same for the same work, for example. Equity would be nothing to do with economy or ecology. It has to do with respect. Are we treating each other with respect? Racism, sexism. Equity in the environment, are you exposing people to toxins in the workplace and in their products? Is that fair? Is that fair? It's a form of intergenerational remote tyranny. It's a form of chemical harassment. I mean, think about it, right? I mean, it's just, that's the way I see it. And then if you look at environmental equity, we're leaving behind polluted atmospheres and rivers. Is that fair to future generations? Environment, are we following the laws of nature? I'm an architect. I have to follow the law of gravity. It's not just a good idea. It's the law. So, like, what other laws are there? Right? So this is, am I following the laws of nature while I do business? That's pretty fun, actually. We'll talk about that. And this is eco-efficiency. Am I being efficient? But the problem is, everybody talks about triple bottom line. This is a manager's job, the bottom line. The executive's job is revenue. Isn't that interesting? So they talk about triple bottom line all the time. It's bottom feeding. Sorry. So, you know, it's, am I being efficient? But if you reduce your water and energy consumption by 10% and you save $20 million, you say, isn't that exciting? Yeah, but like, what were you doing last year? Throwing away $20 million on stuff you didn't need. I mean, what does this have to do with the environment? Now if that's 10%, you just reduced your environmental damage by 10%. I mean, now you're only 90% damaging. You were doing bad business, throwing $20 million away for stuff you didn't need. Don't tell me it's an eco program. It's an economic program, see? So, financial profit, and then CSR, corporate social responsibility. Business for social responsibility. So what we're saying is, let's create revenue. Let's get ecological revenue. I'm going to show you buildings that can restore biodiversity. Right? Let's talk about equity, revenue, more people treated more fairly. More, not less. Okay? Very different. Now, Archimedes has been misquoted. Listen to this. Give me a lever and a place to stand and I can move the earth. That was in a very famous newspaper recently. What's missing? Fulcrum. No fulcrum, no lever. Right? You have to have something that does not move. Right? Otherwise, you're just poking at the world. So we see cradle to cradle, as I show you, as a fulcrum. It's a rock. You can lean on it. And then we can lean all these kinds of questions on it and see what happens. And then we can move the earth up instead of crush it. Okay? So we created something, this is the new book called the Upcycle. And essentially we say, take an inventory of all this stuff going on, put it through an intellectual filter, which are your values, and in products we consider that the safety in human mother's milk. Human mother's milk now contains 2,500 chemicals that don't belong there, and we don't think this is fair. And so, or healthy. So that's, if you want to be certified, you can't have that stuff. And then we look at what is the stuff we want to get rid of, and then what do we want to do, and we do them both. Okay? Now being less bad and going to zero is a good thing because you're on an upward trajectory. Okay? So the second thing after we see and think is to rearrange the furniture. So we created Cradle to Cradle certification as a way to think about these products. And we started by looking at their materials and their chemistry down to the parts per million, parts per billion. This is 1990. And start characterizing them. We looked at priority criteria, no more cancer, birth defects, genetic mutations, so on. And we looked at toxicity questions in vertebrates, plants, persistence, heavy metals. And we wanted to know where things came from, where they went, what went into that. And so the first product I ever designed actually was a fabric in 1994 for Steelcase, and brought in Michael Braungart and a whole bunch of chemists, and we just looked at the rivers where the water coming out of textile universe, and we designed a fabric so clean you can eat it. Changed the chemistries. After looking at 8,000 chemicals, we selected 38. And now the water coming out was as clean as Swiss drinking water. Now when a textile mill reduces cost by 20% and produces water as clean as Swiss drinking water, welcome to the next industrial revolution. And now the trimming, instead of being declared hazardous waste, which it had been by the Swiss government, and was being shipped to Spain. Can you imagine that? You trim your cloth, that's hazardous waste, and then you sell what's in the middle? Equal sign here. Yeah. And now it's sold as, or donated as mulch to the local garden club. So then we brought in technical nutrient concepts to the carpet industry, and then worked with a bunch of people, and had to move away from the people making PVC carpet, even though they claimed environmental credential, because of the furans and dioxin potentials there. So we didn't find that okay. But we designed a new carpet, polyolefin and thermoplastic backing, and nylon 6 caprolactam based fiber, and put an 800 number on the back of it, and it's now the largest selling, it's the largest carpet company in the world. Isn't that cool? Anyway, you're storing your raw materials on your customers' floors. What an idea. You see? Isn't that beautiful? So we have 1.4 billion pounds of carpet waste in America every year. What if it was all able to go back and become carpet again? And so we keep our textile industry, we store our materials on customers' floor, and we stay in relationship. Yay. So rearranging the furniture, this is Steelcase and Herman Miller, two of my early clients, and it's really wonderfully dedicated companies. And you can't make a chair that's not Ecological certified at these companies now. And the materials are all designed to come apart and be used again. So regulations are signals of design failure. This is the regulatory environment really since 1920. Imagine that. And look at this one. These are environment regulations. This is chemicals. Anybody worried here? Yeah. So the question is, what if we can get rid of this by design? So that's what Cradle to Cradle is about. It's about designing for material health, reutilizing materials in new business models, leasing concepts, refurbishment protocols for various kinds of things, material pooling, and clean energy, clean water, and social fairness. So we add, to reduce, reuse, recycle, we add redesign, renew, regenerate. And we move from a take, make, waste linear economy to a take, make, remake, retake, remake, retake, remake, while we restore. And I call this either or, because you can either go to the mine and look for gold at $210 a ton, or you could harvest cell phone circuit boards at about $7,500 a ton, just in gold alone. But in other metals too, it's worth about $27,000 a ton of circuit boards from telephones. Isn't that amazing? Yeah. And there's a person who's developed a cradle-to-cradle system, so the water is clean at the end after taking out, I think it's 1,000 fractions. Quite astonishing. Anyway, so the first industrial revolution, nature never sent us a bill. Isn't that something? So the next one, we'll probably have to do something similar. So we started looking for materials. I want to do housing for 2 million people. So I started looking, where can I get materials cheaper than free? Yeah. And so you look at packaging. This is 2 years ago. These are the award-winning packages that year. Not one is recyclable. Not one. Can you imagine that? That's what we're doing. So this is it. And we go, oh, isn't it great that the poor can have little sachets so they can celebrate this too? Yeah. And then it goes to the oceans. This is brand new from Science Magazine. Look at this. China is the top one. Indonesia, Philippines, Vietnam, Sri Lanka, Thailand, Egypt, Malaysia, Nigeria, Bangladesh, South Africa. Look at that. We made it into top 20 over here. down there at the bottom. But look at that. And so, what are we supposed to do about all this? What if it was an asset instead of its liability? So I started working with the waste companies to try and figure out, what is it all worth? How does it all move? How do we turn it into value? So I decided to grab a hold of a package just to play with it. And I'm now designing packaging, quite a bit of it. Anyway, so I got this at Whole Foods. And I noticed, it says gluten-free, non-GMO, not baked, not fried, Do you see a recycling symbol? No. So it's not those. Well, what is it? Well, it's also a package you're selling, not just the interior. And look, I don't see any recycling symbols. It's gluten-free, vegan, raw, not recyclable. It should say maybe not recyclable. Anyway, and these are the contents in there. Okay, but I decided to sell you the package. I'll eat the kale chips and sell you the package. So here's another version of the package. Now made of paper and plastic. Non-recyclable, not reusable. Oh, let's be free of something that kale never had. Let's be plutonium free. Why not? Easy. Not certified anything. Non-vegan, plastic sticker applied, verified. So then we took and made we put the nutrition facts of the container: undefined polymer mixture, neurotoxic metals, persistent bioaccumulative pigment, hydrocarbon soup, and volatile organic compounds. Right. Anyway, so then we sort of said, let's take a blank sheet of paper, and I'm working on the cereal box. Why? Because I asked a simple question: why are cornflakes in a box made of old magazines with mineral-based inks that are volatilizing through the high-density polyethylene bag into the cereal itself? Why do we have to fight our way into a cardboard box with our cuticles, rip apart glue, tear cardboard, and then attack a plastic bag with a pair of scissors or a knife, or exercise our biceps to get into the cereal that we want, and then the package is really hard to close? Genius. So why wouldn't we make packages for cornflakes out of corn stalks? That's what we're doing. Anyway. So there's a whole bunch of things. So then we build, after we've rearranged furniture. So this is Oberlin College, 1992, a building like a tree. This building makes 13% more energy than it needs to operate, purifies its own water. Building like a tree. This is Ford Motor Company. I was given an assignment of redoing this thing on the left in public by Bill Ford without telling me. And when I said, why'd you do that? He said, I never would have gotten permission. You've never done an auto plant before, so off we go, produce shareholder value. So we did this, world's largest green roof. It wasn't easy, but it was great. The Ford people were terrific, and we found the green roof in East Germany. The Stasi had built it to camouflage big fighters during the Cold War. It's very lightweight, cheap camouflage to change colors of the seasons. So we built that company here, and then this thing saved Ford $35 million in capital expenditure over conventional stormwater management with chemical treatment plants to meet the Clean Water Act. And so for the board approval, all I had to do was walk in and say, I have a minute and a half. There's only 3 things I want to say. First, this project is for the birds. And that is absolutely true. Secondly, you're fiduciaries in the car business, so I guess we should talk money in cars. The project's going to save you $35 million over conventional engineering day one in stormwater, because you're not burying pipes and asking 70 auto workers to stand around praying it doesn't rain next to piles of chemicals, okay? 35 million CapEx is the same as me walking in here with the Ford Taurus in Chicago, coming out at a 4% margin, with an order for $900 million worth of cars. Approved. Next. We need to talk each other's language. This is the Gap corporate campus, San Bernardino, California, now YouTube's headquarters. Ancient Meadow. We had to get permission to collect the seeds. It's now a native seed nursery. That's a business. This is a brand new factory just finishing in India. This is covered with greenhouses. We put the structure on the roof to keep it out of the space. And it's covered with solar collectors and greenhouses. So there's 400 people inside making things, and there's 300 people working on the roof growing organic food for their children and families. And we use 6 million gallons of water we make out of the air. It's the desert. We take it out of the air. This is a research and development center design in Barcelona. And the lobby decoration is designed as 2 sheets of glass at 2 feet apart. So as you go into work, you get to watch butterflies hatching in the walls. And then on the weekends, the children come and open the windows, release the butterflies into Barcelona. And then they go beat up the Parks Department and the Highway Department about their habitats, etc. There are 50 butterflies going extinct in Barcelona. Why? And these are floor plans. Those are the tile floor plans. Yeah. Then NASA asked me to work on the Mars space station. And I said I can do that, maybe, but I can't work on the red planet until we come back to the blue one first. So I don't know if you remember it. Yuri Gagarin, the first human in space, when his radio signal came in, and they said, "Commander Gagarin, what's it like up there?" And he said effectively, he said, "It's amazing. It's beautiful. It's blue." So we can do this, you know. I mean, we have to be humble, human designers. And just remember this, we went to the moon before we put wheels on our luggage. Don't forget that. Humility is very important, and it took us another 20 years to put 4 wheels on the luggage. Right. So anyway, we started in the room where they heard the words, "Houston, we have a problem." And this was the design team. And so I said, you know, we say here on Earth, you don't need to be a rocket scientist to do something smart, but what if you were? So who did this? This is a nuclear-powered facility. The reactor is 93 million miles away. It's 8 minutes and it's wireless. Did you figure that out? Uh-huh. We invented the photovoltaic. Good. You're in charge of energy. Now, can we drink our urine up here? Yep, sure can. It's $80,000 to get water up there per gallon. Sure we do. Forward osmosis. Good. You're in charge of water. Now remember, words matter. Words matter. You know, there are 3 famous initiatives trying to get sewer water to become drinking water during droughts: San Diego, Sydney, and Singapore. I don't know if you heard the results, but Sydney and San Diego didn't do too well. You know why? You know what the initiatives were called? Toilet to tap. Words matter. You know what they called it in Singapore? New water. Go figure, who wants old water? Amazing. Anyway, so these are the design team, and then we decided to work, you know, somewhere easy where you can grow almonds. And so here it is at NASA Ames, it's down there on the right. It was built ahead of schedule, normal budget of a federal office building. This building has the potential of making 120% of the energy it needs to operate, gives it to its neighbors. And it's a building like a tree. They call it sustainability base. You know, the first thing they cut off on our designs is always the sunshades, because they're easy for the value engineers. They go, "What's this?" "Oh, that's sunshades." "Oh, don't need those." So I made an exoskeleton. So this is the structure of the building, so there's no columns inside. And you can't cut off my sunshades because the building will fall down. And here, Park 2020 in Amsterdam, we see the building as continuous assets. So actually we're building with steel instead of concrete, and we're developing things that go together in certain ways, so that at the end of a 15-year lease, if the building can be reused as an office building, it's ideal. If it can be converted into housing, it's immediate, because we designed it as housing, actually. And then if you wanted to tear it down and make a park or something bigger, the materials are all tagged, and we know what they are as commodities. And if you just built out of concrete, you would pay 80 euros a square meter to get rid of it. If you design it the way we do, it's worth 180 euros a square meter as commodities. Because we watch the markets, concrete just turns into aggregate, but steel's going up 10% a year. So you design with what's next and what's now. So this is underway there. And it's the largest collection of cradle-to-cradle certified materials in buildings anywhere in the world. We helped Catalina Island with their master plan here, and just offshore here. Really wonderful project. We spent a lot of time with Catalina. What a beautiful place. We also, with the Annenberg Foundation, we came and looked at this village, this housing that the Navy had, and they were trying to figure out how to build there, but the Palos Verde blue butterfly is extremely endangered. It might be the most endangered butterfly in the United States. And the question was, could we bring the women back from Afghanistan and give them housing and still have a habitat. So the question became, let's just call everybody the blue butterflies. And we'll take care of each other. So that broke a loggerheads, so that we're at it. And this is a project we just finished helping with a master plan and concept for LA. This is the Port of LA. And here's our design, our concept design. And it's to be laboratories for ocean research, for enterprise and things like that. And I basically took the interpretive center and thought of it as, what about this little thing floating around telling us a story? And I thought, what if the interpretive center was actually a giant shard of ice melting into the ocean? And we could show movies on it. It's LA. And so there's a little movie here, I think. Here we go. This is the first phase. We prepared the master plan and concepts for it. So we made this little video of some of the elements. The iceberg is sitting in this concept sketch in a field of tile, blue tile with little mirrored tiles. So it sparkles like water. The laboratories are all renewably powered. Seawater is brought here for the researchers. At the end of this way is something I call the theater of infinite possibility, which would be a place to dream here. With various skin, you could bring boats up to it, you could have events there. And here we are coming back toward the iceberg. It's solar powered. The shade devices for the rooms are giant doors that flip up and create shade and balconies. And it sits in a pool of water. The conference room is below the water. And it'd be an unbelievable place to premiere a movie, don't you think? Yeah. So this is a conceptual piece to let everybody understand that the oceans are such a critical place for us to be thinking and working. And so I get to work with a lot of ocean peoples with the World Economic Forum as well. And so this was a notion and an evocation of something that we start to render things beautiful. Because if you look at the whole notion of beauty as a driver, it's a fundamental thing, as you'll see in our lexicon, because this is something I call atmosphere. This is where you take water out of the air and drink it with the hydrological cycle, which we use to purify our drinking water around the world. And so let me just go on here. And there's the theater at the end. And it just looks out to the west and out to the ocean and the infinite possibilities. So, the University of Virginia, designed by Thomas Jefferson, I lived in this house at the bottom left, was a Platonic library, rotunda. It was a sphere inside a cube with a pediment, and the library is in the dome with illumination and all the books, and with windows. And the floors below have two ovals in them. So this is the mother arts. This is the egg. These are ovaries. It's not, you don't need to be a rocket scientist to figure this one out, right? So it's the mother arts. Truth and beauty and culture. And then you look at the arcades, the colonnades, and this is Aristotle. This is truth in science, in number. There are 10 pavilions, decimal. Right? There are 100 students. They're in between the 10 pavilions, which is the classrooms and the faculty. Okay. And then the south end is open to nature. So behind you are the arts and culture, your history. To the right and left is the number and the science, the search for truth through number and data. And then, you know, like engineers famously say, in God we trust, all others bring data. So, right, this is the number. And then the south is open to the Blue Ridge Mountains, nature. So just in case you have trouble with symbols, that's a floor plan. Nice floor plan, by the way. Beautiful room. You can hatch stuff up in there. So here it is, and that's the Great Lawn there. And then what happens in 1904? The Victorians. Destroy nature. You can't see it anymore. So this notion that you could think about beauty and culture, and you could think about number, and then you could look at the wonder of the natural world, all of a sudden, here we are, 1900. So I want to ask us if we can't start thinking of values and value differently, where we start to think about designing with our values. And then we develop principles. We use the Hanover principles. Then we create our visions. And visions without execution are hallucination. We understand that, right? So then we set our goals and our objectives. Then we develop our strategies, tactics, short-term strategies. Then we measure, and then we show value creation. See, that fourth thing, if I had started saying I'll do 2 chemical treatment plants and 3 kilometers of pipes instead of 4, that's eco-efficiency. Less. But we never would have made the breakthrough if we hadn't started with Bill Ford saying, what is the right thing to do? Express your values first. And what happens then is we can use the creative values to do value creation. A very famous educator in America who has taken 16-year-old kids, dropped out of school, and I think 87% of the students been through his program have gone on to college and graduated. And when I went to visit him to find out how he did that, he said, well, the first thing you need to know is we never, ever do vocational training. Ever. We just do the arts. Because these children need to establish their own creative ability and confidence. He said, Bill, think of it this way. When these kids come here, they're already spiritually dead. You have to want to be on the planet first before you want to learn algebra. So, how do we treat each other with respect creatively? So, after Katrina, Brad Pitt called me because he had read the book, and we became friends. And he said, let's do something in New Orleans. And we ultimately decided to help bring back the lower ninth itself. And so we decided to build some houses there, and we did. We're at about 103 now, I think. And there are about 20 different architects in our work here. We have a couple of famous LA architects. We have Tom Main and Frank Gehry are here. And we built these houses and offered everybody these choices. And so they're coming back. And my favorite part, really, is that the mother who came to me and said, you know, I know what you did. My children in the FEMA trailers in Texas, they come back to New Orleans, they want to sing and they want to dance, because you can't be in New Orleans if you can't sing and dance. And she said, do you know what it's like having a 10-year-old child who wakes up every morning doing this? And she wants to dance. 4 months later, the kids can sing and dance again. What did we do to them? Think about it. Was that on purpose? Of course not. Can we do better? Of course we can. And if we look out now, we have 50 million people in the world that are refugees. The average stay of a refugee is 20 years. And we put them in these temporary dwellings and they don't have the right to work. Really. So I'm looking at the garbage dumps and trying to figure out how to build housing out of this stuff. Finally, I have the people in the chemical industry that are working with me. It's been wonderful. Terrific support. And I've got something that's going. It's really exciting. And essentially, just imagine that Buckminster Fuller went to sleep dreaming of efficient domes and woke up with the right angle. Anyway, so this is an almost infinitely useful system. This is half a roof of a gabled house, and that's it on a pallet. It's made of 2 pieces. Yeah. And so what big urgent problems have we got? You know, what are the Katrinas? What are the catastrophes that can tell us what we're doing and not doing? Look at this one. China, only 12% of its land is arable. And guess what they declared a year ago? 19.4% of it is toxic. In a green revolution, if somebody increased your yield by 20%, you give them the Nobel Prize. What if you took 20% out and toxified it? What do we call that? The Dumbbell Prize? What kind of prize would we give for that? It's so sad. It's so unnecessary. This is Hunan province. This is cadmium. This is lead. This is a gift for a group in Cameroon, and this is solar collectors. But you have to ask the question, you know, what differentiates this from asphalt? Right, it's blue and shiny, and the weeds are a problem, and the soil is a problem, and really, and you know, I often like to say asphalt can be seen as two words assigning blame. So the question becomes, like, is this it? And so we're looking at, like, really, that's it? What if you put these together and thought about it differently? So SunPower and Total and City of Tianjin are working on this. I'm working on it now. And we're looking at this saying, wait a minute, what's wrong with this picture? The heads are showing. So these collectors run north-south, and then they aim into the east, aim into the west, and so the shadow is moving on the ground. And if shadow moves on the ground, the collectors are tall enough. These are like fruit trees, and the sugar is kilowatt hours. And what does that mean? That means that if we lift them a little bit, and so we can do something, then we can farm under them. And the soils can come back. And we can use these as fence posts, and we can have grazing. We can have fiber growth, and we can have carbon sequestration with deep-rooted plants, and we can have water returning to the water tables, and we can start to bring life back to the surface of the planet while we do this. And so instead of saying to the farmers, you must leave because we have a solar farm, you say, who's the lucky farmer that gets the sweet fruit of the sun? It's a different way of thinking. And we need to go with scale, and we need to go velocity. I've had the privilege of representing the United States in the China-US Center for Sustainable Development, starting in the 90s, for President Clinton, and I've been keeping my work together with them, and now the World Economic Forum has a meta-council for circular economy. My vice chair is Ellen MacArthur, who's sitting there on my right, from London. And here, this is the woman who is now in charge of the new China Association for Circular Economy, and this is the head of the NDRC, who will be negotiating the climate for China, and I'll be working with him on writing the new 5-year plan on the circular economy. It's very exciting. And we've been asked to develop the training programs because we said, let's talk to the young people of China and let's make, in a decade, made in China means the most fabulous products in the world. Let us do that. So we're going to be developing training protocols for all of them. But I think one of the most inspirational people I've ever encountered is this man who passed away 4 or 5 years ago, Dr. Venkataswamy in India, an eye surgeon, created Aravind hospitals, I'm sure you've heard of them. But he was a cataract surgeon, and he said, why is it $1,900 to give cataract surgery when I just need one scalpel and 2 little pieces, 2 lenses, 10 minutes and a cubic meter of sterility? Why is it $1,900? He said, what if I use the tools of mass production so I can bring the cost of lenses from $220 down to whatever they cost if I make them at scale? And then I give it away for free. And by giving it away to people who need it, who can't afford it, for free, I can go to scale, allowing those people who can't afford it to have a massive reduction in price. Isn't that something? What a commercial idea. When Dr. V passed away, I think the hospitals and he had given eyesight to 3 million people for free. And because of this, the scale was so beautiful, the lenses were $2. See, and if you had to pay the highest amount to keep the hospitals going, it was $50. And you could pay whatever else you wanted. Everybody benefits. It's a world of sharing and abundance, not the world of taking and limits. I once asked the head of a big financial investment house in New York what was the secret of Wall Street, and he said, oh, Bill, it's so simple. It's the creation of the perception of scarcity where none exists. And when you think about it, what we have in our current system is this simple question: how much can I get for how little I give? Really? Right? That's the question. Even famous philanthropists ask this question. How much can I get for how little I give? And so it's a world of limits and greed. And so what if we reverse this, like Dr. V, and ask it differently and say it's a world of abundance and generosity and sharing, and we ask the question, how much can we give for all that we get? And 3 million people get to see. Isn't that amazing? So that, I think, is the fundamental question of commerce of our time. And as an architect, I can't help but end with little admonitions. So Louis Sullivan, a great artist actually, is credited with form follows function. And actually, form perhaps follows evolution. But of course in LA, form follows parking. But, okay. And then we have Ms. van der Rohe with less is more, and I'm from Japan, and we like simple, elegant things. But is less is more parsimonious, or is it elegance? Or both, fine. Isn't that, it's really quite beautiful as a modernist, obviously, I care about these things. So less is more, until you have nothing, I suppose. And less is more or less. And perhaps more is more, really. And perhaps there's something even more than more is more. So I'd like to stay here tonight. Perhaps endless is more. So unless you think this talk is endless, I will thank you for listening.